In this tutorial, I will teach you about Spring Boot framework. We will start with the basic idea of Spring Boot, what it is and why it is needed. Then we will create a sample project using a special tool called Spring Initializr. So there is a tool available to easily create new Spring Boot projects. We will talk about that. And then once we start the coding, we will talk about controllers and Spring JPA, which allows us to connect to databases. And then we will finally create a REST API using the Spring Boot framework. Then we will move on to a little bit more complicated or advanced topics in Spring Boot like profiles. And then we will see how to track health and metrics of a Spring Boot application. Then by the end of this tutorial, we will create a distributable jar or distributable application that we can simply copy and run on any system from the command line. So without further ado, let's get started. The first thing we need to answer in this tutorial is, what is Spring Boot? Spring Boot is an open source Java framework that simplifies and accelerates the development of Spring-based applications. So you see, there is a diagram here, and we have the Spring framework here. Then there is Spring Boot framework, and that connects to the user. So the Spring Boot framework acts as a middleware between the Spring framework and the user. If you look at the framework's history, the Spring was released in March 2004. It was a very powerful library. It still is. But the problem with the Spring was it had a steep learning curve. It was complex to configure because it required XML-based configurations, and for a newcomer, it was really hard to get started with. And also the configuration was really complicated due to the XML-based configurations. As a result, in 2014, April, Spring Boot was released. And the main focus of Spring Boot was to simplify the development of Spring-based applications. And that is what is Spring Boot. So Spring Boot make use of Spring framework. So Spring framework is still there, and Spring Boot framework is like a abstraction on top of the Spring framework. Now let us see, why do we need Spring Boot? So the Spring Boot framework consists of Spring framework, has a lot of nice features. I have added 4 main attractions here. This is not all. There are many attractions, many cool features, but these are the most important features when you consider the Spring Boot framework. We will be going through each of these features in detail. So let us first get started with the inversion of control, or IOC. I have prepared 2 diagrams for you, and in the left side you can see the traditional system, and in the right section you can see the inversion of control concept. So let us consider the example of making a car or building a car. So when you build a car, let's say we are programmatically building a car, and the car requires a wheel class or wheel service, whatever it is, and a car has an engine, right? And the engine requires a flywheel and a cylinder, and car has transmission, and transmission has a gear system. So this is just a traditional. So when we are building a car in a traditional system, we have to first create a wheel object and use it in the car. To use it in the car, and we have to create a transmission object, and the transmission object requires another object called gear, like that. In the inversion of control concept, all these instance creations, all these classes are managed by a special entity called dependency injector. So if you look at this example, you can see we have the car, and the car will get all these components through the dependency injector. So it is not directly managed by the car itself. So in the IOC concept, inversion of control, the object creation and maintenance is managed by the dependency injector. This has a very great advantage. For example, here when in the traditional system, when we are creating an engine, we have to first design the cylinder and design the flywheel and give it to the engine, right? And then we have to give it to the car. So the problem with the traditional approach is, whenever we want to change something, it will become very hard because they are tightly coupled. That is the term we use. The traditional system is tightly coupled with its components. With inversion of control, nothing is tightly coupled. Everything is managed by the dependency injector. And when the car requires an engine, it asks the dependency injector to get the engine class or engine object, and it will provide that one. So inversion of controls provides loose coupling of classes or its components and make it easy to maintain and develop. If you haven't understood this concept clearly, that is totally fine. We will be talking about this very much in detail throughout the tutorial. So this is just the overall idea, okay? And then let us talk about the inversion of control versus dependency injection. So if you have already heard about the Spring Boot, you might have heard about dependency injection and inversion of control. And there is usually a confusion between the difference between these two. So to make it clear, I have provided a table here, and inversion of control is actually a design principle. So the difference is very simple. Inversion of control is a design principle and dependency injection is the technique. So they are both the same. One is a concept and the second one is like the technique or the implementation itself, right? So inversion of control is a principle, whereas dependency injection is the technique by which we use to implement the principle. And the focus is how dependencies are provided to a class. So dependencies means these individual services or components that the main program requires. So the focus of the dependency injection is how it is provided to a class. And for the principle, inversion of control principle, the focus is on shifting control of object creation and management. So rather than tightly coupling these systems together, inversion of control shifts the control of object creation and management to another tool, which is the dependency injection. And we have the mechanism injecting dependencies through constructor, methods, and properties. So throughout the tutorial, we'll be seeing how to inject how to inject services and classes into another classes through constructor and methods and properties. And for inversion of control, we have the corresponding principle. And the outcome of these things is to enable loose coupling, improve testability, and increase flexibility. And the inversion of control simply promotes the idea, and the dependency injection implements the idea. So that's about the very first attraction of Spring Boot, inversion of control. The second one is convention over configuration. So one of the major advantages of Spring Boot is it is very easy to get started. For example, when you create a new project, you have the logging automatically enabled. Like you can see the console logs properly. And if you want the file logging enabled, you just have to change one line of code. So the convention over configuration is a software design paradigm that emphasizes reducing the number of decisions that developers needs to make by relying on predefined conventions. What that means is, by default, Spring assumes that this is what you're going to need. It assumes everything that a common person or a common project requires for their applications. So with the logging example, it assumes that you need you need a logger in your application. So I am including that, and it will provide a set of predefined settings or predefined defaults for the applications. So again, coming back to the logging example, when we start the application, we will have a nicely done logging. So all of those decisions are already made for us. Another examples of convention over configuration is when we start an application, Spring Boot application, it starts on the port 8080. So it made the assumptions that by default, everyone is going to need to run the application on the port 8080. If you want to change it, there is an easy way. There is just one line of code you have to change, and that will change the server port. So coming to the points, it provides reasonable defaults. Reasonable defaults mean the default settings that most of the people going to use, and only specify unconventional parts. So convention over configuration cannot cover everything. For example, when you connect to a database, everybody is going to have separate username and password. It doesn't make sense to include a preset username and password while connecting to the database, because obviously, right, the password and username is different for every user. So it doesn't mean including every settings as a default. So only specify unconventional parts. So username and password must be mentioned while connected to a database. So those kind of things will be left unconfigured. And this provides another option, another advantage, that is reducing the number of decisions to be made. So especially for starters, when they create a new project, if they have to make a lot of decisions to just to start the application, that is going to discourage them. That is going to make the development complicated for the people. So the convention over configuration reduces the number of decisions to be made and eliminate distractions. So it also eliminate distraction. Like for example, if someone wants to use database, we just have to provide the database like a URL and the username and password. Everything else is like automatically detected, or everything else is automatically taken from the default values. So by providing that one, we are eliminating distractions for the developers, so they can focus on what is important, which is developing their business logic. And the third one is embedded server. So the embedded server is like when you start, the Spring Boot comes with an embedded server, and you can specify what kind of server you need. So it supports Tomcat, Jetty, Undertow, etc. And by default, this is embedded in the framework. So the advantage is when you want to develop an application and deploy it, you don't have to rely on a separate server. Because if you have developed an web server application on your own without using this framework, you will know how hard it is to configure another server and connect that to our application. So there is an embedded server in the Spring Boot framework. And there is like production ready features. Another advantage is like there are lot of production ready features. These are just four ones I have added that I thought are very important, but this is not it. It provides a ton of ready to use production ready features, which allows us to create production application with confidence. So we will be talking about these things like health checks. We will see how to configure that and how to enable metrics. So metrics is like how many requests have I processed in the last 30 minutes? How much time did it take to respond to a request? Those kind of things will be covered under the metrics. And there is logging. I already told you about the logging example. We will see that in just a moment. When we create a new project, it will have the logging enabled automatically. So if we are going to configure these things on our own in a separate application where Spring Boot framework is not used, it will take us a long time to get it done or get it working properly. But thanks to Spring Boot framework, all of these are provided by default. And I mean, it only takes very minimal effort to enable these things. And there is also caching. So in the web server or in the web world, caching is really important because we have to cache, and the Spring Boot provides a direct built-in caching support as well. So that's about the basic features. I will take you back to the original why Spring Boot question. So we have seen the main attractions of Spring Boot. The next step will be creating a new project, and we will see how to create a new Spring Boot project using the Spring Initializr. So let's get started. Now let us see how to create a new Spring Boot project. So the easiest way to create a Spring Boot project is by using a tool called Spring Initializr. And the Spring Initializr is available online using the address start.spring.io. So once you load the Spring Initializr, you will see a couple of settings. I will walk you through each of the settings. So the first option we have to choose is like what is our build system is going to be. So there is Gradle with the Groovy language, Gradle with the Kotlin and Maven. So for this tutorial, I will use Gradle with the Groovy. And for language, our applications language, we have three options: Java, Kotlin, and Groovy. Let us go with Java here. And the version. So for the version, you can see couple of different versions here, and it might be a little confusing what this snapshot is, what this M1 is. I'll tell you. So the snapshot is the one that is currently in development, so that is like a beta version, and the M1 is also is like a release candidate, or it is also in the development, that is not recommended for production use because it is not finalized. So the recommended version is like whatever the version that do not have the M1 or snapshot suffix. So here we have 3.1.9, that is from the 3.1 release versions, and from the 3.2 release channel we have 3.2.3. so it is recommended to use this one because from the 3.3 we do not have any production releases. And here we have to provide some information like our project information. So I will just give group as com.genuine, genuine coder, and then as the artifact I will learn it as I will give it as learn Spring Boot. Okay. Demo project for Spring Boot, that is good. And we have the packaging option. For the packaging option, that is like when you are building the project, how do you want it? Do you want it as a jar or var? For now, let us use the jar as the packaging option itself. And for Java version, we have two supported versions, Java 17 and Java 21. You might be wondering why previous versions of Java is not available. That is because starting from Spring Boot version 3, like a 3.1, 3.0, 3.1, 3.2, the minimum required Java version is Java 17. So Java 17 or 21 is available. Let us go with the Java 21. Then we have the option to choose dependencies. If you click at the dependencies, you can see a lot of things. For example, if you want to add some like MongoDB database support, you can search for MongoDB and you can see there is MongoDB driver. If you want to, so similarly, if you want anything, if you have to implement reactive programming, I have a tutorial on this already in the YouTube channel. So if you search for reactive, there is reactive web available. For our purpose, for creating a simple web application, we need Spring Boot Starter Web. So simply search for Spring Web and add it. So if you look at the description, you can see build a web including RESTful application using Spring MVC. So we will just add Spring Web that will add everything that we need for the basic web application. So it will contain the Tomcat server and it will contain the other necessary dependencies for building the web applications. And one thing to note is if you want to connect your application to database, then you need JPA, Spring Data JPA. So you have to add Spring Data JPA, persist data in SQL stores. We will be needing this, but at the beginning of the tutorial, we are not going to use the Spring Data JPA. So we are not adding that. I am just telling you that if you want, you can add it right now itself, or you can add it later. So once these options are properly chosen, you can click on the generate button and it will generate the project for you. So it generated it and downloaded the zip file with all the necessary files we are going to need. So I will just open that. Learn Spring Boot, and I need to extract this. So let me use 7-zip tool to extract it. So you can see it has all the necessary files. I will just extract it to my home folder, genuine coder, and let me select the idea projects directory. All right, and let me click on OK. Now let me show you the extraction results. So I have the Learn Spring Boot project here, and it has all the necessary files. Now for development, I'll be using the IntelliJ IDE. So let me open the IntelliJ IDEA, and I can open this project. So I will go to open, and I have the inside IDEA project. So I have the Learn Spring Boot project, and let me click on OK, and that has opened my project. Let me maximize the window for you. All right. So when you import the new project, it will take a little bit time to download the necessary dependencies and all. And here we are. We have the project opened, Learn Spring Boot. And I will just walk you through the structure of the Spring Boot project first. So if you look into the project structure, you can see there is like a source, main, Java, and our package. And we have the Learn Spring Boot application. So only one class is added, one main class, and it has the annotation at Spring Boot application. So for every Spring Boot application, this is important. You have to annotate the main class using at Spring Boot application to detect it that it is a Spring Boot application. And there is one very important file that is called applications.properties. So in the Spring Boot framework, we can control a lot of things using these properties files. So you can control a lot of configuration using these properties files. So we will add some entries here just in a moment. Before that, let us go into the build.gradle file and look at the entries. So here you can see we have a couple of plugins for the build system, and we have set the programming Java version as 21, and we have two dependencies. The first dependency is Spring Boot Starter Web, and it will add all the other required dependencies. I will show you an important or funny or interesting thing. So if you look into the external dependencies, you can see this many libraries have been added by just this dependency, Spring Boot Starter Web. So this include the logging system, the console logging system, and the testing frameworks. And you can see the Spring Boot starter itself. So Spring Boot library itself, Spring Boot dependencies itself. You can see YAML dependencies for reading YAML configuration files. You can see everything. So all these dependencies or external libraries have been added by just specifying the Spring Boot Starter Web and Spring Boot Starter Test dependencies. So a lot of things are happening in the behind, but everything is abstracted away thanks to the Spring Boot framework. Now, let us just start the application. So to start, I will go here and click on the run. And let us make sure that everything is properly loading. And you can see application has started on the port 8080. It started on the 8080 port. So our web server is running properly, and you can see a couple of messages like starting Spring Boot application with a Java version. So all of these things, including this logging, like this nice logo and this logging, all of these are provided as a predefined thing. So this is called convention over configuration. So Spring Boot team made the decisions that when we are using the Spring Boot Starter Web dependency, these are the things that we are going to use, or these are the things we need. So they made that decision for us, so that just by creating a new project, we are started with a web server, we have running it on 8080 port, and we have everything already running and up and running. Now let me just take the browser. So let me open Firefox and go into the port localhost 8080. And currently we are seeing an error page, but we are still seeing our server here. The server do not have anything configured, so that is why we have this error page. That will go away as soon as we configure some endpoints. And another interesting thing I need to show you to illustrate the power of the application.properties is to set up logging. So currently when I run this application and close it, these log messages are lost. So when we talk about the production ready features, when we are running this application on a production environment, sometimes bugs will happen. And it is just a matter of time. So when these kind of bugs happen, we need to find out what exactly happened, right? What exactly went wrong? Was there any exceptions? So these kind of logs are really, really important. So currently these logs are only added into the console. It is not returned to any file. We can change that. We can change that with just one line of code. So if you look into the logging, so just search for logging, and here you can specify logging.file.name. By just specifying the file name, it will start getting added into the files. So let me mention it like this. I want every logs to be added to a file called log.log file, or maybe my log file, right? That is my file name. I want that inside a directory called log. So inside the folder named log, I need to have all the logs in the mylog.log file. I just do that one line of configuration and start the application, and you can see the magic in a moment. So the application is started. I will just refresh the project here. So where do I have the reload from disk? And you can see the new folder appeared, the log folder appeared, and there is a mylog.log, and you can see the entire thing that we see here is shown in here. If I restart the application, it will keep on appending the log. It will keep on adding just below. So while we are running the application, there were 9 lines. Now if I just open it again, can I refresh it, reload from disk, and you can see here it ended at the 9th line, but in the next startup it added these many lines. So this is the record. So we can check these logs in from your production environment to see if something bad happened. Let us see one more customization using the application.properties file. Right now our application is starting the server on 8080 port. Let's say you want to change it. You want to change it to some other port. That can be done also using the application.properties file. So if you look for server.port, you can see that by default, the value is 8080. But you can change it anytime using just server.port equal to line. So let's say I want to make it 8500. That can be done just by using this line. Let me restart the application, and then we will see that the application is running on the port 8500. So this application.properties file is a powerful concept in the Spring Boot framework where you can do a lot of configurations. Let us talk about Spring Boot controllers next. Right now, if I run this application, as you have seen, if I go into the localhost 8500, I am just getting an error page. It is just an error message with some 404 error. So let us start coding so that this page can show some data that we can program from our code. So we will be doing that using the Spring Boot REST controllers. To do so, first we need to create a new class. So I will just create a simple Java class. I will name it as my simple controller. So let us create a class like that. And the first thing we need to do here is to annotate this class using a special annotation called @RestController. So what does this mean is this will mark this class or tell Spring Boot that this class is going to be handling the REST API functions. So we'll be creating a simple endpoint like what should happen when we go into localhost 8500/home, so that we can code in this class. One important thing to note is that we are just creating this class. We are not creating any objects of this class or anything. We are just creating this class and providing this annotation. And as I have said in the introduction, then this class's object and other things will be managed by Spring Boot using its own features. So this is convention over configuration. So it has configured a lot of things in the backend. So nothing extra needs to be done. So I will just provide the annotation as RestController, and then I will start writing a function. Let's say, as always, I want to show hello world when someone goes to localhost 8500, right? That I can do like this. So public string, and let's say I can give any function name. I will just give the name as public string home. And here for the thing I need to do is I need to create a request mapping annotation here. And within the request mapping annotation, I will provide slash as the address. So when I go into any localhost 8500, there is already a slash here that is automatically assumed. So when this page is, or when this address is loaded, it will automatically come into this function. Then I will just return the value hello world, right? I will just return the string hello world. That's it. Let us just run the program and see how far it has taken us. So I am restarting the program and going to localhost 8000, and you can see there is a hello world message coming. So what is happening here is I am repeating this to make sure that you understand this clearly. We created the mySimpleController class, but we haven't used the objects of this class anywhere. We have only two Java classes. The first one is the main class, and the second one is our simple controller. Even though we haven't created any object or linked this to any other functions, it is managed by Spring Boot automatically through this annotation at RestController. And then since we have provided at request mapping for the slash path, it automatically come to this function and return the value hello world. So that is as simple as it gets for using the Spring Boot framework. Now let us talk about the features of this request mapping. So if you look into the request mapping, it has couple of customization we can do. The first thing is like the value. So the default one we provide is like the value, and here you can see it takes a string as the argument. What if you want, what if that you want, instead of just a slash, you want to get this function called some other paths as well? That you can do like this. Instead of a simple string, you can use any other value. So more than one value, that is a string array you can use. So when you take slash or slash home, in both cases, it will load this function and show the value here. Here, I will just show you that. Let me just restart the program. And this is localhost 8500. And even if I go into slash home, it is showing me hello world. And if I go to some other path, it will show error. That is showing a white label error page. That is because we haven't wrote any function for that one. So for those addresses. So that is the very basic idea. Now let us improve on it, right? So here I am saying request mapping, and in the web we have different types of request type, like a get request, post request, delete, put, etc. So by using the request mapping, we allow any kind of HTTP request. Let's say you want to restrict it to some or some specific request types, that you can do like this. So if you look into the functions of customizations of request mapping, you can see that there are a couple of options here, and I will use the one method. And in the method, I can specify what kind of HTTP request I want to accept for this function. So here, if I say request method dot get, then only for get HTTP request, it will call this function. Let me show that to you. So right now, when we use a browser, it is always just get request. I will show that here. So HTTP 8500/home, that is a get request. Now let me open the tool Postman tool to make some other kind of request and show you how it works. So let me create a new one here, and localhost 8500, and I will try with a get request. Okay, so here let me call the function, call the endpoint /home. So send, and you can see I am getting the hello world response. But as soon as I change the type to post, it will show me an error, method not allowed. That is because I have restricted it to just a get function only. And if I change, I can here also I can change it. Let me check the type, and you can see that it is a request method array. That means I can provide more than one method type here. So request method dot post. Right. So here I can specify request method get and post. So right now it should allow both the get and post for my function home. That let us check again. So I have enabled post, and when I click the send request, it is giving me hello world message. If I choose anything else, maybe like a put and patch, you can see that it is not allowed because that is not specified here. Now, Spring Boot is about making the life easier and making the code more readable. So there is a shortcut for this. So instead of specifying at request mapping with the customization of method equal to get and post, you can write the same using another function like this. So let me show that. Public string. Let me call the function as second home. So second home. And here also, I will just say hello world 2, right? And instead of at request mapping, I can write it like this, at get mapping. So what does this mean is it only accepts get request. That is why it is using get mapping. This is equivalent to at request mapping slash or maybe test. Then I will provide method as get. So this request mapping function can be rewritten in a simple way like this slash test. So these two are the same. So by using the get mapping, I am implicitly saying that I want to use the method type get. Okay, so that's about the get mapping. And here you can, so you may be wondering, what about post request? I want to create a post mapping. How can I do that? That you can choose simply like this, post mapping. What about put? You will have put mapping, I believe. Yeah, put mapping is available. What about other delete mapping? So delete mapping is available. So this is a shorthand way of writing the mapping request like this at get mapping. Okay, so that is the basic idea. Now let's say we want to do some calculation. I want to, this is my idea. So let's say I have a function like sum, and I want to send two parameters like a equal to 6 and b equal to 7. So this is what I'm trying to achieve. I need a mapping function for sum, and it should accept two numbers. One is a and one is b, and it should give me the sum of these two numbers as the result instead of hello world. So if I try to execute this, it is a 404 error because we haven't provided a mapping. Let us do that mapping here. Okay, so at get mapping. All right, so I am writing for a get function, get method. So I will name the, I will set the mapping as, or the path as the /sum, and then let me write a function. So return value is going to be int sum like this, right? Now let me write the comment here. This is our URL. We will have an A parameter and we have a B parameter. So we need to access this A and B within the function, right? So that can be done like this, at request mapping. And we will say what is the name of the mapping. So we are going to name the number as a, which is going to be an integer. So I will rephrase, sorry, it is not request mapping, it is request para. So at the request parameter a should be taken to the integer a. And the second one, at the request param b, it should be taken to b. So this a will come into this integer a. This b will come into this integer variable b. Now we just need to calculate the sum. So I will say int c equals, or maybe int sum equals a plus b, and I will just return the sum. Okay. Let me restart the application and see if our coding is correct. So we have the sum a equals 6 and b equals 7. And if I execute it, you can see that I am getting the proper response 13. So we have accessed the request parameter a and b using these annotations. We did the calculation and simply returned the result. So that is the basic idea of controllers, guys. Now, one more important thing related to this example I want to give you is how to create your own services, your own bean class, and use it. So right here, as I have just explained before, we are not using any objects of this class explicitly. It is automatically managed by the Spring Boot. Now let's say I need to create a new service class like a calculator. So I will write it as a calculator, and inside that I will write to a function. So public int calculate sum. I will take two parameters, integer a, integer b. Then I will simply return a plus b. And in a Spring Boot perspective, how do we use this class? So one obvious way you will be thinking, if you're not familiar with the Spring Boot, is like return new calculator, calculate sum a comma b, right? That is the usual way, but it has one problem, that is that it is strongly coupled. During the introduction, if you have seen the introduction, I have told you that we have to use dependency injection, and all these instances are managed by the dependency injector. Inversion of control, that is this concept is called. So we have to apply inversion of control technique and let Spring create this class for me instead of me creating dynamically within the function. So in order to do that, you can annotate this class as a Spring bean, and here since this is a calculator, I can call it as at component. So what you need to do is you have to provide an annotation called at component, and when you provide this at component annotation, the Spring Boot will detect that this is something Spring Boot manages, so it can inject it into the required applications. Okay, so if you look into the documentation, do I have the source? No. Let me download the source. And if I look into the documentation, it says that indicates that the annotator class is a component. Such classes are considered as candidates for auto detection when using annotation based configuration and class path scanning. So what that says is, when you provide an annotation like this into this class, it will be eligible for dependency injection by Spring Boot. Now let us update our code. So in the controller, we have like this new method, that is the conventional approach. So in the new Spring Boot dependency injection approach, we will write it like this: at auto-wired private calculator. And what happens is Spring Boot will create this my symbol controller object internally, and when it does that, it will automatically create an object and assign that value into this calculator class. Now inside this sum function, I can simply use it like this: return calculator.calculate sum, and it will just work like that. Again, to make sure that you understand, note that we are not creating any object. There is no new call for the calculator class. It is managed by Spring Boot. And there is one extra tip for you. Even though this works, this is not recommended. You can see IntelliJ put a warning here. So if you look into the warning, you can see that field injection is not recommended. So there are some cases. I am not explaining the exact cases because it is a complicated scenario. There are some cases where this field injection, like at auto-wired private calculator doesn't work. It has some problems. So what you need to do is to convert this one into a constructor and use constructor injection instead of field injection. This is called a field injection because we have a field here, calculator field, and dependency injector inject value into this field, but that is not recommended. Instead, go with a constructor based injection. So what is happening here is, instead of a field, I have converted that into a final field itself, and instead of injecting from the field, I have specified that in the constructor. And when Spring Boot create an object of this my symbol controller class, it will automatically create an object of the calculator and put the value here, because we are not doing that anywhere. So this is the recommended approach. So you might be asking, where is the auto-wired annotation? Auto-wired annotation is optional here. When you give a constructor like that, Spring Boot will automatically identify it as it is something that I need to inject and use it. To show you this, let's say what will happen if I remove the at component annotation. If I remove the at component annotation and come back to my Spring controller, there is an error here. It is saying that could not auto-wire, no beans of calculator type found. Right now what it is saying is Spring Boot doesn't know how to use a calculator service, because we haven't marked it as a Spring component or Spring bean. So for that, we have to add the @component annotation. So that is the basic idea, and I hope it is clear to you. Let me run the program and confirm that it is indeed working. So we have some A equal to 6, B equal to 7. Let me just refresh, and you can see I am getting the 13 value. And let me put maybe some other number, 69, 68, 75, and you can see 143. 143 is coming. So that's the basic idea, guys. This is the most important part. One of the major features of Spring Boot is dependency injection. So we have seen how to use dependency injection and how to use get and post mapping, how to create the basic REST API controllers. Next, let us see how to serve HTML pages using Spring Boot. So far, we have been using the REST API to give some text data. Let's see how to show actual HTML pages using the Spring Boot. So to do this, the first thing we need to do is to create some HTML pages inside the resources static package, right? So inside resources, we have the static package or static folder, and inside that we can put HTML files. So the first thing I will give is an index.html, so that when I load localhost 8500, this will be loaded, because index.html is the default file name for the home. So index.html, and here I will put some just rough HTML contents like h1 hello, just a simple h1 tag. And we have to change one more thing. Here we said that when the slash path is loaded, it will load hello world. We no longer need that. We will just get rid of this one. Okay, so I will just get rid of this one and start the application. Okay, now let's say I want to go, I load 8500, and you can see that the HTML content is loaded from the index.html. You can create any HTML here as you want. For example, if you want to have a path for HTML like testme.html, you can do that. And here you can write your own HTML content and access this using this path. So you can go into localhost 8500, then test_me.html, and it will load that page properly. To make things a little bit more complicated, let us design a good HTML page using ChatGPT and put it here. Currently, it is just a rough text content, right? So let me open ChatGPT and ask it to write a nice landing page for me. So write an HTML page with CSS for my Spring Boot learning tutorial landing page, right? So let me use ChatGPT to write an HTML page. Yeah, it has started writing some good HTML with CSS. Nice. Okay, so we have the code. Let me just copy the paste that code here into the index.html. Pasted. Now let me restart the application and go into the localhost 8500, and you can see we have a nice landing page here. So you can put any CSS, JS, HTML content here, index.html page or any HTML page, and it will be properly served by Spring Boot. Now, one more thing that we can customize easily is the error pages. Right now, if I go into some non-existent pages like what name should I try? So maybe name itself, right? So localhost 8500/name. This is not specified. We don't have any controllers in the Spring controller, and we don't have any pages with the name as the entry. So when that happens, when any error happens, you can provide customized error pages as well. For that, what you need to do is to create a new folder inside the static directory and name it as error. And here you can put, for example, here the error is 404, right? So you can create a 404 HTML here, HTML file, 404.html, and put it here. And here I will just restart the program and show you that it is indeed loading. So the localhost 8500/name was an error. Let me restart it or refresh it, and you can see it is showing an empty page. Now we can customize this page. You can give any content here in this HTML so that this will be shown when that error happens. So no longer the generic message will not be shown. You can customize the error page like this. Let me again use ChatGPT and make a good error page for the 404 error. Create an HTML error page for 404 error. So let me make ChatGPT write an error page for me, and then we can paste it there. Okay, it is ready. Let me copy paste it here and restart our application. And let me refresh the page, and you can see 404 page not found. The page you are looking for might have been removed, had its name changed, like that. So you can customize any error. This is 404 error. There could be, there are different kind of errors like 500 error, 401, 402, 403. So for all those cases, you can simply put corresponding HTML pages here and do the customization. So that's about the basic ideas of Spring controllers. Let us talk about Spring Data JPA next. So Spring Data JPA, which is known as Java Persistence API, makes it very easy to work with the databases. Every real-world application need to process some sort of data, so a database is necessary. So the Spring Data JPA makes it easy to work with different kinds of databases. So if you look into the world of databases, even with the SQL kind of databases, there are different providers, different companies providing slightly different SQL databases. For example, PostgreSQL, MariaDB, MySQL, etc. So the Spring Data JPA put an abstraction and makes it very easy to work with these kind of different databases. So one of the advantages, you can easily swap different databases. You develop the application using Spring Data JPA for one database, and later you can change the database and keep the same code. Let us start our coding with the Spring Data JPA. So the first thing you need is a database installed on your machine. In my system, I have the MySQL already installed. So it is already installed and configured. And regarding Spring Data, it is a separate project from the Spring Data JPA is a separate project from the Spring team. So we have to add this dependency. To add this dependency, we will go into the build.gradle, and here we just need to add that implementation. Okay, so I will duplicate the line, and here in the implementation, Spring Boot starter data JPA. So here I will put it as data JPA. And I need one more thing. I told you that different kinds of databases are there, even with the SQL. So different databases uses different drivers. In my case, since I have the MySQL installed, I need to include the MySQL driver as well to connect with the MySQL database. So I will just include that dependency as well. For MySQL, the driver is com.mysql, MySQL connector -j for Java. So MySQL connector Java. So with these two dependencies, I am ready and good to work with the database. Let me rebuild the project so that the Gradle will import the necessary dependencies. And if I go into the external dependencies, you can see that it has a lot more new dependencies than we have seen in the introduction. So it has added many new libraries. And if I look for like JPA, you can see that it has started Spring Data JPA, and it should have something called Hibernate as well. So it automatically added another library called Hibernate. If you aren't familiar with Hibernate, no problem. It is just a library called ORM, Object Relation Manager. So ORMs allows us to easily convert Java classes, POJO, Java, plain old Java objects, POJO classes into database models and so on. So it is just that this library is making you, this dependency, Spring Data JPA, is making use of many other libraries internally and making it easy for us to work with. Okay. All right, now we have added these two. Let me just start the application and show you what happens right now. So if I start the application, I am getting an error now, and it is saying that I haven't specified the URL. So I have to go back to the main properties file, application.properties file, where we do our configuration. Here I have to specify a couple of things. Only the most important things needs to be configured. So that has to be done first. So let me take the default configuration template that is out there. So application.properties. I will just paste this one and explain one by one. So for database, we need to have this much configurations done. So the first one, it is the URL, and the error message is about URL. So we have to specify in which port the database is running, and the JDBC connection URL, database connection URL is required. So this says that it is a MySQL and it is running on my own system at 3306 port. Here you can see it is running on 3306 port, and my database name is going to be tutorial, and I haven't created any database named tutorial. So I am saying create database if not exist equal to true. The problem if I don't add this line is I will have to manually go to the MySQL and execute query to create the database called tutorial. So we are adding this line so that everything will be created automatically. Then the next two things are the obvious username and password. So Spring can't guess our password. Like I told you in the introduction, these are the basic configuration that Spring Boot cannot assume. If it could have assumed this, it wouldn't have been asking us about this. But these are the very basic configuration that is different for every system. So we have to provide it. So the username and password needs to be given. Now the next line is called hibernate.dialect. So I told you that internally Spring Data JPA make use of the Hibernate ORM tool, and this one is actually not really required. I have added that in this tutorial because if you have followed some other tutorials, you might have seen this and you might be thinking, why am I not adding this? So the purpose of this one was to specify what kind of SQL this is. Because if you consider the SQL implementations, you can find that there are different companies providing different MySQLs. For example, MySQL is there, MariaDB is there, PostgreSQL is there, Microsoft SQL is there. So different SQLs have slightly different syntaxes. So for this Hibernate tool to properly use the language with the SQL database, we had to provide this kind of dialects, but it is no longer needed. So let me just run the program and show you. It will tell you that you can get rid of this. And here you can see MySQL dialect does not need to be specified. So I have included this in this tutorial because this was used by a lot of people in the past, but it is no longer mandatory. It doesn't do anything wrong if you specify it, but it is not just required. Spring provide that also. And the next entry is spring.jpa.hibernate.ddl-auto. So DDL means data definition language. And the significance of this configuration is when we run the program, we will be creating new tables. So we will be specifying new student table with a couple of fields. And but if we don't add this, what will happen is when we try to save some data, it will show an error saying that the table does not exist. But once you specify the DDL auto, it will be DDL auto as update or create. It will be able to automatically create those tables for us. There are some other options we can give for DDL auto. So you can see create is there, create drop is there, none, validate, and validate is there. So each one has its own purpose. When we provide create, it will create the schema and destroy previous data. So if the table does not exist, it will just create that one. And there is like a create drop, a create and then destroy the schema at the end of the session. So this will create the table, but the schema will be destroyed when we close the program like that. So for now, we will keep the update so that it will create it if not there. And if we change the table structure during subsequent runs that we will do in this tutorial, it will automatically update the table structure as well. So it does all those things for us using the update. That's about the configuration part. With just these 4 lines, we have successfully configured our database connection thanks to Spring Data JPA. Let me just run the program again and make sure that the program is starting properly. And you can see that we have some new entries and it is successfully connected to the database. Now, the next step is we need to create some classes that will be converted into tables in the database. So for that, I will create a new package and I will name the package as model, and I will create a student student class. So this is just a Java class, right? Just a normal Java class. We want to provide an annotation to this class to let Spring Data know that this is going to be a database entity. This is going to be a database table. So that can be done using the @entity annotation, right? Using the @entity annotation. So if you look into the documentation, it says that specifies that the class is an entity. This annotation is applied to the entity class. And now there is an error, and the error is that persistent entity student should have a primary key. So as per the SQL criteria or requirements, every table should have a unique primary key, right? A primary key as an ID or something. So here the IntelliJ has automatically detected this class as a Java persistent entity, and it is showing that error. So the first thing, obviously, what we have to do is to specify a field for our ID. And to annotate that this is going to be an ID, a primary key, we have to use the @ID annotation. And that error is gone. As soon as I have applied the @ID annotation, that error is gone. Now, as we all know, in the SQL tables, we have to keep on incrementing this number, right? IDs are usually automatically incremented when we add new data. Like the first student will get the number 1, the second student will get the number 2, 3, 4, and so on. So that can be done using the annotation @generated value. So let me put the annotation here. And inside that generated value, we have a couple of options. Specifically, we have the strategy. So how would you like to have the value generated? So we have to use the strategy option, and we have to specify what kind of generation type we are going to use. So the best approach at this point is to use the generation type auto. So what auto does is, it will tell the Spring Data JPA that it should pick an appropriate strategy for the particular database. So it is like telling the database, hey, choose whatever the approach you think is best. So if you think the sequence-based generation, so what are the ways we can provide an auto-incremented value? We can have a sequence in the SQL. SQL sequence is a thing, and using that sequence, we can keep on incrementing a value and provide value into the student. Or we can use its own table, a dedicated table. So if you look at the available options, we have sequence, which uses that persistent provider must assign primary keys for the entity using a database sequence options. There is an identity option. So if you choose identity, it will choose another approach and it will provide entity using a database identity column. There is a UUID option. So this UUID is actually for string-based identifiers. We will be exploring this just after some time. So we will cover the UUID generation in the upcoming chapter. So just wait for a moment regarding that. Just remember that UUID is for UUID based identifiers or primary keys. And then we have table based option. So when we provide table generation type, it will use a database table to ensure uniqueness. Okay, so we will use the auto option here and let Spring Data choose whatever is best for us using for the given database. So that is the first thing. And the second thing I need is I need a name for the student. So I will mention it as private string name. Then let's say I need an email. So private string email. So these are the fields of our student. So every student will have an ID, a name, and an email. Okay. Now I will add some getter and setter, alt insert. Using alt insert, I can get this generate option, and I will choose getter and setter, and I will just add getter and setter for this one. Okay. Now we want to create the student, right? We have specified the student entity. And to work with the student entity, we have to create a repository. And the repository interface is something that Spring Data JPA provides that makes it very easy to communicate with the database. So here we have specified the structure of the entity or specify the structure of the table. Now we have to create an interface or a kind of service that can communicate with the database for this entity. So for that, I will name it as student repository. And just like any other Spring classes, we have to provide an annotation here. And this is going to be at a repository. So this is also a special annotation that we haven't used before. And at a repository indicates that an annotated class is a repository originally defined by domain driver designs and so on and so forth. So basically what this means is it will define this class. We will convert this into an interface in a moment, but it will convert this class into a repository that can be used for communication with the database. Okay, so here I want to convert this class into an interface and extend it with the JPA repository. And this JPA repository is from Spring Boot Spring Data JPA package. So JPA repository, and it takes two arguments. And the first argument is like, what is the class of the entity? So the entity class is student. And the second option, ID, what type of ID does this student use? So here, if we look into the ID, it is of long type. So we have to choose the option long here. And that's it. And this is kind of like a magic. So the thing is, if we want to use this repository for saving a student or getting a student, we don't have to do any code at all. We just created this interface, and using the dependency injection, we can create an object of this repository and work on this. I will show you that in a moment. It is, if you are new to this, it is like very weird because we are not writing any code, but it actually works. So to illustrate this one, let me create a new controller here, student controller. Okay. So I will create a new controller class, and I want to make this as a REST controller, just like before. And here, let's say I will write a function, public student create student. So here I will just create, let's see how to create a new student. Okay. So I have a create student function here. And here I will add an annotation, request mapping. And here, what should I give the path? So what path should I give? So let's say student/save. So whenever someone call the student/save, I want to create a student and save it to the database. Okay. So let's see how we can do that. So for now, I am not taking any data from the user. That we will do in a moment. First, let us just create a dummy student object and then save it using the repository. So my student equals new student, and I will set the required value. So set name, maybe genuine coder, my student dot set email, the genuine coder, at gmail.com. So I will provide these two values. I am not providing the ID because the ID is provided by the database automatically. Now I want to save this. How can I save it? So the saving can be done by auto wiring. So at auto wired, private student repository. So even though this is an interface and it doesn't have any implementation, Spring Boot is capable of creating an object for this one and auto wire that into this variable. And I will use constructor based injection because this is not recommended. So I will click on Alt Enter, and IntelliJ will provide me like a create constructor option. So this is just like field or dependency injection, but a better approach. So I have this repository here. I am not explicitly creating any object, and repository dot save, and I can simply say my student. So you might be wondering, where did the student save function came from? I didn't write it. So that comes from the parent interfaces. So in the controller class, sorry, in the repository class, we have extended our repository with the JPA repository. So it has a lot of functions on its own. You can see it is extending more and more other repository interfaces. So it has like a find, save, delete, all these things are already available there. So I just use that save function from the parent interface and use it to save my student. Okay. Now, once the student is saved, I want to return the student so that I can check whether the ID is properly applied or not. So I will just return the saved student. Let me restart the application and take the postman. So let me take the postman and let me make a GET request. So localhost 8500/student/save. So that is our URL, like, right? student/save. Then let me send a request. And you can see that the student is properly created. It got the ID 1 automatically assigned, and the name and email is properly taken into the database. I will show you the database structure in a moment. So for showing you database structure, I am using a free tool called dbeaver. If you are not familiar with this, you should check it out. It is a very great tool. It is a community tool, free edition, free universal database tool, and it has a lot of nice features like showing relationship between tables and basically everything that you need to do for a database. It is available in this tool. So this is the dbeaver tool. Let me refresh the database, and I have the tutorial database available here. And if you look into the tables, we have two tables. One is student and one is student sequence. So when we provided the auto generated value option for the ID, internally it created a student sequence. And if I look at the student sequence, it has some internal value 51. This is not exactly integer, I believe. And if you look at the student table, you can see that it has ID 1, the genuine coder at gmail.com, and the GC as the name. If I execute it again, let's say I send a request again, you can see that another student got created with the same an email, but the ID is different. ID is 2. Now, if we come back here and refresh, you can see that there are 2 rows, and the student sequence has a value something like 101 or something. So internally, it uses some other representation that is hidden from us, but in the end, it provides us with a proper ID value for each rows. So that is the basic idea of the JPA. So we have created this student object like this, right? And the student object is created and it is saved into the database. Now let us see how we can find a user by their email address. So for that, I have the student repository, and here I will use the options I have to create new query functions. So let's say I need to find a user by their email address, right? So I can do that by student. So I need to find a student. So student find by email, just like this. And I can give an email. So again, if you are new to, very new to the Spring Data JPA concept, this might sound like too good to be true, because we don't have to write any implementation for this function. So we are just specifying the function signature here in the interface. So the return type is going to be a student, find by email, and we are providing an email as the argument. And internally, it will convert this into the SQL query, like a select star from student where yes.email, student where email equal to email, something like that. So that is the beauty of this Spring Data JPA, and I will show you this. So we can have like a student find by email function signature alone and use it here. So I will use another request mapping here, student find student, right? So I need to find a student, and I will change this as find student. And here what I will do is, in the repository, I will use the function find by email, and I will give my email there. So genuinecoder@gmail.com. Currently there are 2 students, so one of the student object will be returned. That doesn't matter. This is just to show you how the custom querying works, how to query some data from the database. So this is the basic idea. Now let me restart the application. It is restarted, and go into, let me create another Postman request. So localhost 800 student find, right? So the endpoint is find. That's fine. So using the find, I will just send the request, and it has a internal server error. Let us see what the error is. So query, the error is saying that query did not return a unique result. That is because I created using the same, I created two students with the same email address, right? So that is the problem. So for now, I will just change this. So this genuine coder I will change to maybe afsal@gmail.com, and I will save it. I just saved it. So now if I query with the email, there is only one student with this email ID, right? So far so good. I will go back to my Postman and send the request again, and you can see it properly found the student by the email, the genuinecode@gmail.com one. And if I change the code here, if I change it to afsal@gmail.com and run the program again, let me take Postman, send the request again, and you can see it found the second student. So ID 2, name GC, and email is afsal@gmail.com. So that is the basic idea, guys. That's the basic idea of Spring Data JPA. Now we will improve the functionality of this application. Rather than just creating a student using preset values, we need to receive the student from the request and save it. So let us make those changes. So we need to update the first request mapping by a bit. So instead of using just a request mapping, I want to make this into a post mapping, because in the RESTful APIs, for posting data or for creating new entries, we rely on post request. For getting some data, we use get request. To post something or to save something, we use post request. So that's why we are using post mapping. And the create student function name sounds fine. And in the argument, I will use request body, and I will receive a student here. So what is happening here is, for the post request, I can send a post body. So for the request, I will be sending a post body, and that body will be a student object. And this student object will be accessed here, and I can simply save that student into the database like this. Repository.save student. So using Postman, we will send the student object and save it to the database. And here also I need to make some adjustment. Here I am just always searching using the afsal@gmail.com preset email. Let's say I want to make it dynamic. I want to receive the email address from the request and process that request like that. So for that, I am changing the the request mapping into a get mapping. Usually when we want to fetch some data, the method type, the HTTP request method type we use is get. So that's why I'm using the get mapping, and I will change it a bit here. So find by email, right? And here I will use @request parameter. @request param, and here as the parameter name I will use email, and I will take that to a string value. So there could be a confusion. You might be wondering, why did I use @request param here while I used @request body here? That is because when you are sending a post request, you can send a request to body along with it. But when you send a get request, there is only like a request parameters. The get mapping usually doesn't have any request to body with it. So that's why we are using @request body here and @request param here. And I will show you the difference in sending request while doing the same. So you don't have to worry about that. So we have the request parameter email, and I will send that email as an argument to this function so that I can find the student using the proper email address. Okay, let me restart the program. And first, let me try with the student creation. So we have the student./save. So here, to create a new student, I will use the post body. So the get should be converted into post, and we have to make use of the JSON body. And using JSON, I will specify the data I need for the student. So let me take the student structure there and prepare the body. So I'm writing a JSON body here. And in the JSON body, I will specify the name as, what name should I use? So maybe Bruce again, Bruce Wayne as the name, and and the email I will use Bruce at Wayne.com, something like that. Let us save the user, and it is saved. So we have a problem here. The ID is currently marked as 53. The name and email properly got applied. So we gave the data, it was accepted and sent to the database, and it automatically generated a unique ID as well. So that is also fine. But the ID is not exactly sequential. It is a unique ID, but it is not the perfect. So that is one problem with the at generator value generation type auto. So here we said that choose whatever you think is right for this database. And it did a good value where each ID is unique, but it is not properly incrementing like 1, 2, 3, 4, 5 like that. Instead, it went on to 1, 2. Then after restarting the server, it is saving like 53, 54, 55. Now maybe if I restart it again, it might go to 100, 121 like that. So that case is there. To fix that, we have to make use of generation type of identity. So it is saying that when we use the identity generator value type, it will use a database identity column. So this is recommended for MySQL databases. So let me change the strategy into identity, and let me go into the database. So let me open dweaver, refresh, and let me remove the data for now. So let me remove the tutorial database and start fresh. So I have removed it. I need to restart the application, and let me take the postman and send the request again. So Bruce at Wayne.com. Okay, now the ID is 1 and the name and email is set. Let me restart the application again to make sure that even after restart, it is properly processing. So let me take postman again, another user. So here I will give the GC again. So the genuine coder at gmail.com, right? Then let me send the request, and you can see that now it is 2, and it will be fine from now on. We will be making more requests and confirming that. So far so good. So we have created the student controller, and now we are able to create students from the postman by sending the request body. So here we have specified the request body and gave the JSON value. This JSON value was accepted as student. Then it was sent to the repository to save. And now let us see how to work with the find by email. So let me go to this tab, and here I have the student that student/find option. Let me change that to find by email. And here I need to provide a parameter here. So I am not using the request body here because this request does not have a body. Get request does not support a request body. So we have to provide a param, and that is why we are using at request param here instead of at request body. Okay, I hope that is clear. And here I need to provide an email. So I need to find user by their email, right? So I need to find Bruce Wayne by their email. So let me check Bruce Wayne's email. Let me refresh the database, tutorial, tables. And now we only have the student table. The sequence is not there because we specified to use the identity column, not a sequence. So that's why the student sequence is no longer there. So here I will take the Bruce at Wayne.com, that one, and give that email value here and send a request. And you can see that it properly searched and found the user Bruce Wayne by using the email. Let me give the genuine coder and also confirm that. So the genuine coder at gmail.com. Let me send the request, and it properly found the student using the email ID. So far, so good. We have the student post mapping and the find by email get mapping. Now let us improve this entity. Let's say we want to make the email column unique, right? I don't want any duplicates because we had a problem with that initially. So that can be done. Let me check a moment. So that can be done using @column annotation. So there is an annotation called @column, and the @column provides couple of customization. So you can see it supports like a nullable. So you can specify whether is null supported in this column or not. The focus here is like the unique equal to true. So when we set @column unique equal to true, then there will be a unique constraint applied to that column and duplicate values will not be allowed. Let us confirm that. So to do this, I need to delete the database again because I changed the database structure. So let me quickly do that from the dbeaver. Let me just drop the table, delete, yes, and run the program again. Okay, the application is started. I will send the request here, gc, the gmail.com. It created the user, it created the student with ID 1. Let me send the request again with the same email address. And it says that there is an internal server error. So there is that internal server error because we provided duplicate email ID, and it says that duplicate entry for key, that is for the student, that unique constraint. And we can see that in the database structure as well. If I take this dbeaver tool and refresh the database and go into the property section, there are these columns. So the ID is of big integer type. So the Spring Data automatically created a big int column for this ID. And for email, it is varchar, name is mapped to varchar. And you can see that there is a unique constraint on that one. And for the name, we haven't specified any special criteria, so it doesn't have any unique constraints. So that's it, guys. That's how you provide these kind of constraints, like a unique constraints. You can also provide like a nullable equal to false, and many other options are available in the column. Let us just have a look. So name is there, unique is there, nullable, and insertable, updatable, length, we can specify the length, like currently it is varchar 255, right? So we can't save more than 255 characters in this column. If you want to increase it, you can specify the length option. So you can say like length equal to maybe 1024 characters. Let me do that. And let me try one thing first. If I do that without dropping the database and refresh it, does it change? No, it doesn't. So let me just drop it, delete, yes, then restart the application. Okay, application is restarted, refresh, student, and you can see that the varchar 255 became varchar 1024. So that's how you customize your SQL column using the annotation @column. So that's a basic idea. Let us see how to update a student using their ID. Let's say I want to update the email address of a student using their ID. So let's see how we can do that. So first we need to decide what kind of HTTP request method we need to use. So if we look into the Postman and see the available options, we have get, post, put, patch. For updates, usually the patch option is used. So I will use that. So instead of get mapping, I will use patch mapping. To be clear, you can use any type of mapping. You can even use post mapping or get mapping. It is just a convention. Okay, so there is nothing wrong with using get mapping also to update, or maybe post mapping also to update the student. But just for convention, let us go with the patch mapping. And here, student, I will just give it as update. And here, the first thing we need is like the ID. So we need the student ID, which is going to be a long value and long ID, right? So we need the student ID to find the student. Then we need @request param. And here we have to provide the new email, right? And here we will give Spring email, right? So we have the ID So we will find the student using the ID and change their email. Let's see how we can do that. First step is finding the student using their ID. Thanks to the Spring repository that is already written. So if you look for function find by ID, you can see that I can simply pass a long value and it will return me a student. So I will just give that here. And you might be wondering, how did Spring Boot know that it is going to be a long value? That is because in the student repository, I specified that the ID or the primary key of this class is of long type. So that is how it is finding the, how it is understanding that the type of the primary key is long. So find by ID. So I will find the student here. Student. What is the problem? So find by, yeah, it is returning an optional student. So that is understandable because if I give a wrong value for ID, there will not be any student. So to avoid the null pointer exception, it is using the optional. So we will do it like this. If student is present, then we will use student.get to act our student object. So student object. And here we can say like student object dot set email, and we will simply apply the email provided by the user via Postman. So student object dot set email, then we need to save the student, right? So student repository dot save student object. That's it. So you might be wondering how it is getting updated. Why did I use the save for the creating student as well as for saving student? That is because this is where the primary key comes into play. So when we fetch a student from the database, there is a primary key. No two students can exist with the same primary key. So when you make a save request with the same primary key intact, it will update the student instead of creating a new one. I hope you understood the concept. So that's why I am using the save here and here. Okay. So far, so good. And once I save the students, I will simply return. And if there is no student, I will simply return the null value. Okay. Let me restart the application and let me load the database dbeaver to show you the current situation. So currently, how many data? I don't have any data in the database. Okay. So in the Postman, I will create a new user. So student GC, the genuine coder. Okay. I have created one student. And then let me go into the patch, create a new request. Let me create a new one instead of changing this one. So patch localhost 8500 /student/update. And here, what is the required data here? So we need the student ID, right? So I will take this first student ID, which is 1 student. So student ID 1. And what is the new email I want to apply for the student? So here I need to give the email and new email at gmail.com. So theoretically, when I click on the send button, my genuine coder user student's email should become new email at gmail.com from this one, right? So let me send the request and it says that it is a bad request. Let me check what happened. Required request for new email for method parameter type string is not present. So it is saying that new email is not present. And that is because I just used the email only here. So I have to use new underscore email and send the request again. And you can see that for the same user, for the first student, it updated the email to new email at gmail.com. Let us confirm this. Let us confirm this by going into the table and refresh, and you can see that the email is updated. So that's how you do the update. So the basic idea of update is find the existing object, find the existing student from the database, make the necessary changes, and save it. It will automatically update it. Let us see how to use custom SQL queries in the Spring Data JPA. So far, we have seen that we can just use these kind of functions to create queries. Here we are finding a student by their email, but sometimes this is not enough. Sometimes we have to use our own custom SQL queries, and Spring Data JPA support that as well. We can use our own custom SQL query to fetch data from the database. So next, let us see how to do that. So in my database, I have added 4 users. So I have like 4 users, and some of them are using Gmail. So their email is ending with @gmail.com, and some of them have other domains. Let's say I want to write a database query where I need to find students with a specific domain name in their email. So for example, I want to find all the students who has a Gmail email. So let's see how we can do that. So to do this, we need to write a function like this. So there is going to be a list of students, obviously, right? Because when we use a specific domain, there will be more than one user or one student that matches with that domain. So list of students, find by, then let me use another thing called domain, right? So find by domain, then I will use a parameter like a domain parameter, and I will give it as like this string domain. This will make sense in a moment. So what I'm trying to do is I am writing a function like this, and here I need to write an annotation for query. So inside this annotation, I can write custom query. So let me write the SQL query for this. Select yes from student yes where yes.email like %.domain. So what this mean is, sorry, it is not dot, it is colon. So the meaning of this one is I need to find the students where their email end with the given domain. And here as domain, we will give @gmail.com or @vain.com or anything.com. And this domain is taken from this parameter. So we can give any parameter, or we can give any domain as parameter here, and this domain variable or domain argument will be taken by the query and it will fill it. Okay, so find by domain, and let us write a controller for that. So here I will update it at GetMapping. So we have the find by email option. So let us create a new one that names as like find by email domain, right? Find student by domain. And here from the user, we will accept the required domain. So domain, string domain. Then we will pass on that into the repository. So repository find by domain. And here, of course, we have to return a list of students, right? So this should solve the problem. Let us run the program and make sure that it is indeed working. So the application has started. Let me create a new one, and it is going to be a GET request. So localhost 8080, and instead of student save, so it is going to be find by email domain, and we have to pass a domain here. So I will pass the domain as @gmail.com. Maybe just gmail.com, right? Then send. And here you can see that we have 2 students with gmail.com domain, and I can actually query with other domain as well. So I have like @genuinecoder.com. One user is there with @genuinecoder.com domain. So let me give genuinecoder.com send, and you can see there is one student using that domain. And I can give something non-existent while something like this and send the request, and you can see there is no result. So that's it. That's it, how you provide your own custom SQL query when you want to, right? And actually, this one can be changed to these kind of annotations as well. Like you can write a function that generates the custom query, but I have written this query, custom query, because I wanted to show you how to do custom queries in the using the Spring Data JPA. So that's it, guys. That's about the Spring Data JPA. We have, let me just recap. So we have talked about the entities. So we have the student entity, and so that will become a student table. We have the primary key with the generated value. We have the unique columns, and we talked about the repositories. So we have the JPA repository with all the good functionalities, and we wrote the find by email. So it will be this will automatically generate the necessary query, SQL query, to find the student by their email. Here we are providing our own query, and we have created the REST API using this repository. There is one more thing I need to tell you about the Spring Data JPA. I told you that during the introduction that I will show you how to use UUID generated values. So let me just show you that. So here in the student, let's say I am going to use generation type UUID, and instead of a long ID, let me use a string ID, right? And let me change the get run setter. Okay, so I have changed the get run setter, and in the repository, I will have to change it as well. So I will have to make it as a string, as it's a string also. And we will have problem with a couple of controllers here. So this one has a problem. So I will just comment it. What else? Yeah, the rest is good. And let us run the program. Let me just drop the database. Let me just drop the table. Delete. Yes. And let me start the program. So previously we were using long ID. Now we are using a string ID with a generation type UUID. And let me start Postman, and let me create a user. So I have student.save API to create new students. So send, and you can see this ID is created like C3CFF. That is called UUID. So instead of just always incrementing numeric IDs, you can also use this kind of unique UUIDs, and the UUID will never collide. Like if you are worried about like two students getting the same ID, that will never happen. As an additional information, let me just show you. So UUID collision chance. So if you search for UUID collision chance, there is this saying. So according only after generating 1 billion UUIDs every second for the next 100 years, the probability of creating just one duplicate would be about 50%. So if you generate 1 billion UUID every second for the next 100 years, the chance of two UUIDs becoming the same is like 50% only. So it is that much unique. So in my personal experience, in all my development experience, as the primary key, I have been using the UUID because it never collides and it is very safe. And it is also faster. It is also faster in the sense we don't have to worry about always having the next incremented number. We can just have any UUID generated internally and use it. So that's it, guys. That's about the Spring Data JPA. Let us talk about profiles next. The profiles concept in the Spring Boot framework is very useful when we are developing actual real-world applications. Let us see how we can use it. Let us first start the existing application so far we have developed. And the first message, the second line of the log says that no active profile set, falling back to the one default value default. That means we haven't configured any special profiles, and it has only one profile, which is the default profile, and it is using that one. So let us learn how to use these profiles. So let me tell you, so when we go into the application properties, we have this kind of configuration like a Spring Data Source, username and password. Very often, the username and password for databases are different for production and developer environment, right? For dev environment, we usually use very simple password, whereas in production, we use some other settings. This is true for many configuration, not only for the database connection, but also for logging and server port and etc. It is very different when it comes to the production compared to the development environment. So using the profiles concept or profiles feature, we can easily provide different kind of configuration based on the profiles that are active. So currently we have only one profile. Let me show you how to create more profiles. For example, I'll be creating two profiles. One is for developer, which is called dev, one for production. So creating a profile is very easy. You just add a hyphen to the application.properties file and specify your specify your profile name. So here application production.properties, and here I can add all the properties for the production. So here I can use the production password, maybe like my complicated password, something. So if your production has a separate password, you can use it. If you want to run your application on a different port, let's say in production, I want to run on 8600, I can do that here. And similarly, to create another dev profile, I can create another file like this. So application dev.properties, and I can have entirely different configuration in this file. For example, here in the server's port, I will set it as 8500, and the rest I will keep the same. So I can have any kind of customization I want. The default application.properties file can contain all the shared configurations between these different profiles. For example, let's say this spring.data source URL is same for all the profiles, then we no longer have to define it again and again in all these properties files. Instead, we can get rid of these two lines, like these two lines, from these two profile files and keep the default values in the application.properties itself. So it is kind of like inheritance. These special profiles are inheriting from the main applications.properties file. And here I no longer have to keep server.port because in these two profiles, I am specifying this server.port separately. So no need to specify that. Also, I can get rid of the log file because if in my production and developer environment, I have the same logging requirement, I can just get rid of that and keep that value in the applications.properties itself. So that is the basic idea. So make sure that you understand the application.properties is the base, and each profile can have its own customization through its own configuration properties files. Now let us run the program. It should go into an error. Let us see. Yeah, it is having an error, right? And the error is saying that, let us see the error message. The error is saying that it is not able to find the proper dialect because it is not able to connect. That is because we have moved some important configuration from this properties file to the profiles, but we haven't specified which profile should the application use. If you go to the first line of the application, let me just move it. So the first line of the log says that no active profile set, falling back to the one default profile that is default. So it is still running in the default profile, but the default profile it does not have the enough information to connect to the database. To choose a profile, you have to use spring.profiles.active within the applications.properties file itself. So in the application.properties file, put this line spring.profiles.active and set the profile you want to start your application on. So for now, let me set it as dev. So the application will start in the developer profile. So here you can see the second line of the code. You can see that the following one profile is active, which is dev. So it automatically identified that there is like a dev profile, and it chose the dev profile based on this configuration we have given. All right, now let us see what is the port it took. It took the 8500 port because we have specified the server.port as 8500. In our production, we have the port as 8600, right? Let me change that to 9000 for easily seeing that, and change the profile to production profile, right? So it should start the application in the production profile. Let us check the second lane. You can see that the following one profile is active, which is production, and it started the application on 9000 port. Now, if I go into the application, into the browser, localhost 8500, it is actually not loading. It is just waiting. And if I go into 8000 9000 itself, you can see that the application is running. So by just switching between these profiles, I was able to change the server's port. This is just an example. You can have any kind of customization done through these properties files. And so we have seen how to customize the configuration for each profile, right? But that is not all. We can apply this in the code as well. So if we go into the my symbol controller, let's say I want to customize this controller based on the profile that is active. To link this class or bean into a profile, I can use the @profile annotation and give the value like this. So in the production, I want to use this RestController. So what this means is when the application is running in the production profile, when I take /home, it will come into this class, into this controller class and return hello world. When I go to /test, it will show this message. But I can customize this for other profiles. For example, let me create another controller, my symbol dev controller. And here I will have dev. And in the dev, I want to make some customization. So when the /home is called, instead of hello world, I want to show the message, hi human. Hi human, like that. And when the test is called, I want to show some message like maybe prove me that you are not a robot. So that message will be shown. And I want to get rid of this /sum in this profile, right? And I can get rid of this auto-wired calculator service as well. So this is for my developer profile. So let me show you how it works. Let me switch to developer profile in the application.properties and start the application. Okay. Now let me go into 8500 /home. And you can see it is showing the message it is showing the message, hi human. So what is happening here is when the developer profile is running, Spring Boot automatically identifies that this controller class should be loaded instead of this controller class, because this one has a profile production and it should be created only in the production profile. So this profile was created, and when I called /home, this function was called and the hi human was returned. Similarly for /test, if I go for /test, you can see prove me that you are not a robot message is coming. If I go for sum function, we had a sum function, right? A equal to 6, B is equal to 7. That no longer exists. It is going to the 4 not 4 error. That is because in this profile, the RestController do not have any mapping for the sum endpoint. So there is no sum function available. Now let me switch back to the production. So let me change the profile back to the production and start the application. And you can see that it is starting on the port 9000. It is starting on the port 9000. And if I go here, 9000 /home, you can see that it is showing the hello world from this controller, from the existing controller we had, hello world. And the sum function should now work. So sum equal to A equal to 6, B equal to 7, and that feature is working. So the profile is very powerful, and it is not limited to the configuration. It can be used in the whole program, including in the Java code. And you can have very different behavior based on the active profile that is set. And changing profile is as easy as changing the application.properties spring.profiles.active entry, right? Now you might be asking, like, I build a jar file, I give this build to a customer. How do I change it? Because this application.properties is something that is bundled within the application itself. I mean, what I'm trying to say is, when we provide this application as a software to a customer, we can't change this file, right? Application.properties is not editable at the customer side. If at the customer side, if you want to change, what can we do? So for that, there's a JVM argument possible. Let's say I am not specifying the springs.profiles.active here. Okay. But when I start the application, I give a JVM argument. So let me show you how to do that. So I should have some option here, modify. add VM options, right? So in the VM options, I can specify -d spring.profiles.active equal to dev. Let's say we want to run it in the dev production. So I no longer have that in the properties file. I am specifying that at runtime. You can see that it is choosing the profile dev. It started the profile in the dev environment. Similarly, if I to confirm that it is indeed working, let me change that to production. So let me set that here as production, apply, okay, start the application. And you can see it is using the profile production. So at runtime, while starting the program using the terminal command like java -jar, then jar name, you can specify the -d spring.profiles.active, and you can change the profile at runtime like that. Let us talk about health and metrics features of the Spring Boot framework. Let's say you have given your application to your customer, it is on the server, and you want to keep track of the server's health and other metrics to make sure that the application is behaving as expected, it is not having unexpected load, the database is working fine. So those kind of production things needs to be taken care of. So Spring Boot is a complete framework. So it provides functionality for almost everything that you can imagine, including this purpose. So they have a very comprehensive tool for health and metrics using a library called Spring Boot Actuator. So it is a sub-project in the Spring projects from the Spring framework. And once you add the Spring Boot Actuator, you can see what is the health of your server and your database, whether it is currently up or down, what is the status of the database, etc. You can also get a ton of information about the process that is running on the server. So let me show you how to do that. So the first thing we need to do is to add a new dependency into the build.gradle. So let me just duplicate this, and there is this thing called a Spring Boot starter actuator. Actuator, Spring Boot starter actuator. And let me rebuild the project so that the library will be downloaded. And I need to provide one configuration in the application.properties, and that is going to be about the endpoints that is available. So here you can see we are providing these options. So management endpoints web exposure .include. So we are saying that the Spring Boot actuator provides a couple of options, including health and info and other metrics. So we want all these things. We want all these things enabled, and we want to enable the details. So we are saying that endpoint should enable the health options also. So provide these two configuration in the application.properties file and start your application. It is as easy as that. You will be blown away by the amount of details you can get from these 3 lines of code. Okay, so we have started the application. Let me check for any health information here. Actuator. Do I see any actuator? Yeah. So here you can see in the logs, you can see exposing 3 endpoints beneath the base path / actuator. So we will be having 3 endpoints: health, info, and metrics. So let me take the Firefox, go to what is my production. Yeah, I am running production build. So I will use 9000 production profile. And here in the 9000, let me go into the health. It should be, instead of health, it should be actuator / health. I will just go into the /actuator, and you can see it has a couple of options here. So it is saying that you have these paths. You have actuator / health available, actuator / info available, and actuator / metrics available. So let us go into the actuator / health. And it has a couple of interesting information. So the response is in the JSON format. The Firefox browser is providing that in a nice readable way. So here you can see the database. The component database is up. So that means the database is running, and the database is MySQL, and the disk space, I can see about the disk information. So let's say you gave the application to your production and you want to check like how much disk space is left, because as soon as the disk space is gone, the application will stop working because new data cannot be added, new cache cannot be created. So the disk space is an important param. So you can see, I can see the total available and the free available, and the path of the application currently running from, and it exists true, and the ping, the server is pingable. So a lot of quick glance information is available under the health option, right? Now that is not all. That is about the health. Let's say you want to get some more information. So let me check the info. Info is not much, but the metrics. So in the metrics, you have all this information that you can query. So if you ask me, like, I want to see the number of requests that has processed since the application started, let me check for requests. Is there any count? Buffer count, CPU count, process. Let me look for the value, right? So we have the process related information. We have the JVM related information. We have the executor related information, and we have the HTTP server request information. So this should provide us with the number of requests it has served. So if you want to see more information about a metric, you can actually duplicate the tab and put that value as slash. So here it is saying that it is giving me all the necessary information about the processed request. So it is saying that I have this kind of actuator info request came, and the actuator metrics request came, and the number of, can I see number of requests? Yeah. So you can see the number of requests served was 8. So if I go into another URL, let's say localhost 8500/home, right, and refresh the metric, you can see the number of requests became 10, and it is also showing that people are going into the home. I mean, the application is serving /home path as well. So this is like a complete analytics of the server. It is showing me which URLs are being accessed by the users and how much time it is taken for each request. So here you can see the base unit is seconds, and the total time it took to process these requests was like 0.08 seconds, and the maximum time it took to process a single request was 0.01 second. So this is, you can see these errors also happened, and regarding the status, 200 is like the normal response, 404 is the error response. So all these kind of information is available under one metric. So if you want to see more information, that is all available here under the metrics. So if you want to see like more information, let's say I want to see disk free information, or I want to see the application starter time. This is like how much time it took to start the application. So the application took 4.7 seconds to start. So this is useful for optimizing the startup of the application. For example, if someone say like your application is taking too long to start, you can actually use this metric to see whether it is improving or not. So similarly, we have a lot of things we can use. So there is like a process uptime. So what this means is how long the application has been running. So it has been running for 388 seconds. If I refresh it, it has been running for 392 seconds, like that. So a ton of information is available, and all of this required like what? 3 lines of configuration, and that's it. And there is one more thing. So let's say you don't want to expose this information into a public user. Like if anyone is able to access this information from our server, that's a security breach, right? So there is option to provide login for these kind of metric endpoints, like a /actuator. You can put under a login wall. So you only after login, it will be allowed to access. Actually, about this login and all, I have already created a tutorial in the name of Spring Boot Security. You can go and watch it if you are interested. And you can also do this based on the profile. So we just talked about profile, and you can actually enable these endpoints based on profile. So let's say in the production, you don't want all the endpoints, but only the health endpoint is needed. right? You don't want to give the metrics in the production profile. You want to give only the health information. Then you can customize that here in the production.properties files. So that kind of infinite customization is possible. And if we want, we have all the data we need. So that's about the health and metric from the Spring Boot framework. Let us see how to distribute our Spring Boot application. So far we have developed our application. We made all the customization we want. And now let us see how to build an executable jar file so that you can give it to the customer and customer can use it right away. So this is also made easy by Spring Boot. Thanks to Spring Boot, this is also very easy to do. So simply go to the Gradle section in the task and look for the build. So boot jar, yes. So look for the build options, and inside that there is an option called boot jar, and simply run that Gradle task boot jar, and that's it. It completed, and it should have generated the executable file. So we will go into the build folder here to get the executable jar file. We will go into the build folder, and there is a thing called libs, and here you can see there is a 48 megabyte jar file. So this jar file contains all the dependencies it requires. It is runnable, and we can just start the application right away. So let me show you how to run it. So we start the terminal like this. Let me use a terminal here rather than a PowerShell. Can I do that? Yeah, I can use a command prompt. Yeah. So here we can use the java -jar command to run this jar file. So java -jar learn Spring Boot. This is not in the proper folder, right? Let me set my folder correctly. cd cls java -jar. Then I will give the learn Spring Boot snap.jar. And here you can see the application is starting. It is starting in the, it is starting properly. And here you can see the production profile is set. It is using the production profile. That is because I have specified spring.profiles.active in there. And it has started. Now let me load the Firefox browser and see if it is reachable. So localhost 9000, because the production build is on 9000 port, you can see we are running the server properly. So this is not from the IntelliJ. We are running this application from the command line, and we can access any API we have created. So we have even the metrics information. So Actuator, health. So all the information is available from the application. We can also change the profile of the application at runtime. So currently it has started in the 9000 port using production. So using the -d spring.profiles.active equals production. It is already in production. In dev, I can actually start the application in dev. So all this kind of customization while running the application is possible. Let me confirm this. Let me go into 8500, and you can see it has started on the 8500 port. So that's it, guys. That's how you build your application into an executable jar file so that you can share it with your customers and run it on any server you want. That's the basic idea. That's it, guys. That's about the Spring Boot tutorial. We have covered a lot of things. So when we say Spring Boot, it is a very big topic. It has an ocean of sub-dependencies on its own, different frameworks, sub-frameworks. So we have covered maximum that we can in this tutorial. If you have any specific requirement for tutorials, please let me know in the comments. I will try to create. And if you would like to see more Spring Boot related tutorials, I have attached the link to my playlist, Spring Boot playlist in the description of this video. You can check it out. I will just give a final conclusion for this tutorial. So in the introduction, we said that we will be covering these topics regarding the introduction to Spring Boot, what and why. So we saw why we need Spring Boot, why it was created in the first time on top of Spring. So that was for simplifying the development of Spring, because Spring framework was very hard to work with. It had a steep learning curve. We created new project using the Spring Initializr from start.spring.io, and we downloaded that project from that tool and then opened it on the IntelliJ IDEA. We created controllers using the @RestController annotation. We served static HTML pages. We talked about Spring JPA in detail. We connected to our MySQL database and created the student entity, did a lot of operations on them. Basically, we created new student, we updated student, and we found student. We queried students based on their email and other information. And for that, we used REST API. So we used REST API and accessed that using the Postman tool. And we talked about profiles. We saw how to set up multiple profiles, how to create developer and production profiles. We saw how to activate those profiles even using the jar file. We saw how to set up the health and metrics, very simple steps, but very useful information. We discussed how to customize the health and metrics based on the profiles that is active. And we also saw how to distribute the final application using the jar file. So that's it, guys. That's about the Spring Boot tutorial. We have covered the most important topics of Spring Boot framework. This should surely help you get started on this framework. If you want more details on any of these topics, please let me know, because each of these topics actually deserve its own tutorial, its own in-depth tutorial, because that much customization is possible. But or creating separate tutorials for all of them is not really possible. So if you're interested in any one of them, please let me know. I'll try to make one. So I hope this video helped you to learn something new today. I'll see you on the next one. Bye.